Okay, Assalamualaikum class. So this video will cover on chapter 1.3, which is feedback, feed forward and cascade control system. Okay, what we will cover in this video: first, introduction, feedback control system. The keyword for this feedback control system is closed loop, monitor and response. Third, feed forward control system. The keyword is overcome disturbance. And lastly, cascade control system. Keyword is nested control system, primary and secondary controller. Okay. The aim for this subchapter 1.3 to understand the concept of the feedback, feedback plus feed forward and cascade control. So later on I will explain in detail about this feedback, feed forward and cascade control. Okay, our course learning outcome is the student should be able to recognize and differentiate each of existing control system. Okay, as for introduction, commonly the control system are based on principle of feedback control. The function of control loop is to maintain. Please remember back. The function of the control loop is to maintain the control variable as close to the set point as possible. Okay, this control loop, please remember we have inside there's a controller, we have an actuator, we have sensor. All of this set of instrument will become a control system, and then the function is to maintain the control variable at their respective set point. Okay, now I will explain about the feedback control system. So this feedback control system is work on principle that process will deviate from set point before control action is applied. That means from the process itself, there is a deviation, the output going out from the process already deviate from the set point before the control action is applied. So that deviation we measure and we cater back using the controller decision, like what I'm mentioned inside the previous video. Okay, next, use of different signal determined by comparing the actual value of the system variable to their desired value to make corrective action. Like what I'm saying, the process output will be measured. That output normally have slight deviation, and that output, the actual value of that output will be compared with the desired value, which is our set point, and then the controller will make a corrective action. Okay, next, system output is used to regulate its input, such as a device is to be a closed loop control system. So like what we learned before, closed loop control system, we have a controller, actuator, process, output, and then the output will be measured and then return back to here. So this one is our input set point. Okay, this is the closed loop control system. So this feedback control system is the solution to most control problem. Okay, so now I will discuss the example of feedback control. So in here, the control objective is to maintain the temperature of the liquid out. Okay, so we want to maintain this temperature, right? Liquid out. Okay. Okay, so let's discuss. Okay, now we have control variable, which is our temperature of liquid out, and then the manipulated variable is the steam flow rate, because we can see here there is a actuator connected at the steam in flow rate. So this actuator will regulate or manipulate the steam flow rate coming into the system. Okay, for the sensor, we have a temperature sensor here. It's used to measure the temperature, the output temperature. This 100 degrees Celsius is our set point. Okay, so this is our controller. Function is to compare the set point and also the PV. PV stands for process variable. That means our output, our temperature outlet. So this actuator actually known as a valve. This valve is used to provide the corrective action, like what I'm saying before. It will regulate the flow rate of the steam coming into the system. Okay, so basically this is the block diagram for the figure before. Okay, just now we have a set point 100 degrees Celsius, and then we have a controller, temperature controller, we have a valve, final control element, process, and also we have a sensor, and there is also a disturbance. So normally in the form of transfer function, the transfer function is a function for each of the instrument inside the control system. So for the controller, we can denote it as a GC. This transfer function is in the form of X function. Actually, this is the same like what we learned about X function, like y into mx plus c, right? So this is a X function, right? Fx. So transfer function in here is Fs. Okay. So for valve A, GV, process GP, sensor GS, disturbance GD. So when we rewrite the block diagram and put the transfer function symbol here, we can say we can rewrite like this. So GC, controller, valve, process, disturbance, sensor. So like what we know, we learned before, we have control variable CV, and we have measured value of CV, CVM, we have disturbance DS, we have error ES, we have manipulated variable MV, function of S, we have set point. So limitation of the feedback controller is overcoming of disturbance and effect of time delay. So it will not cater the disturbance and also time delay or dead time. So in order to improve disturbance rejection and effect of time delay, single loop feedback controllers can reject disturbance to certain extent only. To ensure more precise control of process, some control strategy are used. For example, feed-forward control and also cascade control. Like what I'm saying before, feedback controller cannot cater with the disturbance problem and also time delay. So in order to cater this problem, we have another type of control strategy, which is feed-forward control and also cascade control. Feed-forward control is a general methodology for compensating for measured disturbance. Okay, later on I will explain in detail how they compensate the disturbance. Cascade control is used to reduce the effect of specific type of disturbances. So basically, cascade control is one type of the advanced control. So the simplest one is feedback control, and then we have feed forward plus feedback, and lastly is cascade control. So feed forward control system is used to compensate for disturbance in the system before they affect the control variable. Remember just now for feedback control, they will cause the process output to deviate first. After the deviation occurred, and then they will measure and cater and overcome the deviation using the controller, right? So for the feed forward, it will remove the deviation first in order to ensure that process variable coming out from the process achieve their set point. So feed forward control system measured a disturbance variable, predict its effect on the process, and applies corrective action. So the differences between the feedback control, feed forward will measure the disturbance first. So here, measured the disturbance, and then the controller will take an action and ask the manipulated variable, ask the finite element to regulate the manipulated variable that fit into the process. A bit different as compared to the feedback control, whereby we measure the process output, right? So we measure the process output, and then the deviation of that process output will send to the controller, and then controller will regulate will send the information to valve, and valve regulate the manipulated variables in order to cater the deviation problem. But this time we measure the disturbance, not the process output. Measure the disturbance and make correction based on the deviation of that disturbance. Okay. So this is the example of feed-forward control. Okay. Please remember just now for feedback, we measure the process output, right? The liquid out. So, and then we regulate the steam in. So for feed forward, the control objective is to take corrective action affected by disturbance, which is temperature of incoming liquid, flow rate of incoming liquid. So here, the sensor is at disturbance side. So in this system, we identify two disturbance, which is temperature of the incoming liquid and also flow rate. So this liquid in is measured. So, and then after the sensor already measured the two condition, and then it will send the information to the feed forward controller, and the feed forward controller will do a corrective action based on the measured value of disturbance, and the feed forward controller will ask the valve finite element to regulate the steam flow rate in. Basically, it is not compulsory to have two disturbance. Sometimes in the system we only have one, but sometimes we have more than two. So depend on the system itself, and this depend on the disturbance itself, whether that disturbance is highly affect the process output. If that disturbance didn't affect too much to the process output, then we can neglect it out. So for the feed forward control, the purpose is taking corrective action. The sensor in here is measure temperature of incoming liquid and also measure the incoming flow rate here. So function of the valve here is to provide corrective action by regulating the steam flow rate in. So okay, now we learn about feedback plus feed forward control. So before we learn feed forward, just now we learn feedback, right? So feedback plus feed forward is the combination of the feedback control scheme. Okay, like here, this one is a feedback because it measures the process output and then send the information to the controller, and then the controller send the information to the valve, and it will regulate the steam flow rate in. And in the same system, they install together the feed forward control, like what I'm saying before. So that's why we call feedback plus feed forward control. Clear, right? Okay. Feed forward control always used with feedback control to improve performance over simple feedback control. So feedback control just now, it is required to track set point changes. So why the feedback control required to track set point changes? Because here we can measure the process output. So from here we can know that the process output is deviate from the set point if there is any changes to the process. So feedback control is used to track set point changes. Meanwhile, feed forward control is to measure and control disturbances that are always present in any real process. So this combination made a great combination, because we have feedback control to track the set point changes, and we have, before the system deviate from the set point, it's already read the deviation from the disturbance itself. Okay, so this is the block diagram for feedback plus feed forward control Okay, basically the bottom one here is a set of feedback control. Meanwhile, the upper part here is the set of feed forward control. So we have a summation of those information or those signal, and we can note it as a feedback plus feed forward control. Those signal both is sent to the final elements to make an adjustment. Okay, so now we can see clearly the difference between feedback, feed forward, feedback plus feed forward. So feedback, we measured the process output in order to track any deviation of process output from the set point. Okay, for the feed forward, we measured the disturbance in order to cater any deviation that, in order to eliminate any deviation that will fit into the system. So when we eliminate the disturbance at first, we can say that the system is stable enough and will achieve its set point. But in order to cater to measure the process output and to track the set point changes, we can use the combination of feedback and also feed forward here. So simplified block diagram for feed forward and feedback control. So like what I'm saying before, the feed forward block diagram, normally the arrangement is normally at the top of the process. Meanwhile, for the feedback controller, the arrangement of the system is at the bottom of the process. So for the feed forward, the sensor will measure disturbance and ask the controller to make an action based on the deviation of the disturbance here. And then for the feedback here, they will measure the process output and then send the information to feedback control to do some adjustment. Okay, advantages and disadvantages of feedback and also feed forward. So feedback control loop is a corrective action occurs as soon as the control variable deviate from the set point. The control variable same like process output. So once the process output or control variable deviate from the set point, it will take the corrective action. So next is corrective action occurs regardless of the source and the type of disturbance. That means this corrective action done without take into consideration of type of disturbance of any other sources. The other advantages is requires little knowledge about the process. It also versatile and robust. For the feed-forward control loop, it takes corrective action before the process is upset. So, actually, it eliminates all the unwanted variable or unwanted input. So, for them, if they eliminate first, the system will be stable and the process can achieve the set point successfully. So feed-forward control loop most effective for slow process and for process with significant dead time. So feed-forward control loop does not affect system stability. So disadvantage for both feedback and feed-forward. For feedback, no corrective action is taken until deviation in the control variable occurs. Not like feed-forward, they do a corrective action first before the deviation is occurred. Okay. The other disadvantage of feedback control loop is incapable of correcting a deviation from set point at the time of its detection. Okay, next disadvantage, process may not settle out. Okay, for feed-forward control loop, disturbance must be measured, required more knowledge of the process to be controlled. This is because sometimes we do not know about the information about the disturbance. So that's why we need to study more on the type of disturbance that will affect the system. We need to study about the sensitivity of each of disturbance and the effect of the control variable. So next is require more sensor and model for each disturbance. Lastly, the disturbance variable must be measured online, because sometimes the fluctuation occur not constantly. Sometimes it occur only at certain time. So that's why we have to measure online. Okay, now I will explain to you for exercise 1. Okay, a boiler drum with a conventional feedback control system is shown in figure 4.10. The level of the boiling liquid is measured and used to adjust the feed water flow rate. So the available measurement include the feed water flow rate and the steam flow rate. Okay, so we have a few variables, which is boiling liquid, we have the feed water flow rate and also steam flow rate. Okay, this is a list of available variable. So each one of that variable can be our control variable, can be our manipulated variable, and disturbance variable. Okay. Referring to figure 4.10, draw the feedback control loop of the system. Determine the control objective of the system in question 1. Discuss the problem that might be occurred when the feedback control scheme is used in the system, draw the feedback control loop of the system, determine the control objective of the system. In question 4, draw the combination of feedback and feed-forward control loop system. Okay. So feedback control loop of the system. So now we have to measure. Okay, our control objective is level of boiling water, right? So for the feedback control loop, we have to know we will measure the CV, right, control variable. So now the control variable is the level, this level of boiling water. So this is the level transmitter is used to measure the level of the boiling water, and then if there is any deviation or any signal, any measurement that it takes from here, it will send to the level controller, and then level controller will do a comparison. So we input in set point here. If let's say we want 7 cm, so it will do a comparison of what they measured here and the set point, and then it will send the information to the final element. This final element will adjust the manipulated variable. So our manipulated variable would be feed water flow rate. Okay. So our control objective here is to maintain, like what I'm saying before, level of boiling liquid in the boiler drum at desired value by manipulating the feed water flow rate, which is our MV. This is our CV. Okay, problem might occur. Control system tend to be quite sensitive to the changes in the disturbance variable. So inside here, just now we have 3 variables, right? Inside the question, we have level of boiling liquid, we have feed water flow rate, and steam flow rate, right? So we already mentioned that the level of the boiling is our CV, feed water flow rate is our MV. So the other variable is our DV. So the problem might occur inside the system is control system tend to be sensitive to changes in the disturbance variable and will affect the control variable. In order to cater this disturbance variable, we need to use the feed-forward control loop. So for the feed-forward control loop scheme, like what I'm saying before, we need to measure the disturbance variable and do the correction on the manipulated variable, right? So this one, this FT will measure the steam flow rate in. So this is flow rate transmitter, and we send signal. Actually this dash line is an electrical line. Why we use electrical line? Because basically the controller itself is a digital controller, so it's only receive the electrical signal. So we have to convert here. This transmitter we convert from the pneumatic signal here, pneumatic signal to electrical signal, and this controller will send the signal back to the final element, which is our valve. So this valve will be open or closed, how many percent depends on the level of this tank. Depends on the how many deviation occurred here. Okay. So the control objective of this feed forward is maintain the level at desired value by manipulating the feed water flow rate. The steam flow rate is measured and the feed forward controller is adjusted. So combination of feedback plus feed forward control loop. Okay, we have this one is feedback. This one is feed forward. I hope you all clear with this. So now we go to exercise 2, which is the heat exchanger in figure 4.14 is used to convert the process stream from the inlet temperature to desired temperature at outlet. So our CV is temperature at outlet, right? So that because that one is desired value. Okay, construct the feedback control loop of the system, construct feed forward control loop, and also state the control objective of the system. So if feedback control, so what we want is CV, our CV is outlet liquid temperature. This CV is measured by temperature transmitter, and then we send information to the feedback controller, and the feedback controller will send information to the final element. So feed forward, so we have the other variables, for example inlet liquid temperature. Okay, this inlet liquid temperature would be our stable variable. So basically in the inlet stream also we have a flow rate variable, right? That means we have flow rate liquid inlet, and also we have temperature inlet liquid temperature. So these two variable can be our disturbance. So these two variable is been measured. Flow rate inlet measured by flow rate transmitter, temperature inlet would be measured by temperature transmitter, and it will send to the feed forward controller, and it will ask steam we ask valve to regulate the steam flow rate. So the control objective is to maintain temperature out at desired value or set point by manipulating the steam flow rate. Feedback control scheme, maintain T out, compare T out with T in, and adjust the valve. For the feed forward control scheme, measure inlet flow rate. Remember, measure inlet flow rate, temperature flow rate, inlet also. Adjust steam flow rate to control exit temperature out. So now I move to the cascade control system. So basically, actually cascade control system and feedback plus feed forward control system is a two different control system. So please not be confused. So cascade control system consists of two or more control loop in series. Primary loop controller adjusts the secondary loop controller set point. So in here we have two type of controller. In a feedback plus feed forward controller, we have only one controller. But in a cascade we have primary controller and also secondary controller. So cascade control system control a single variable, and the inner loop controller is used only to assist in achieving this. That means this one primary, this one is secondary. So benefit of this cascade control system is useful in overcoming high frequency noise and disturbances, and also reduce the impact of time delay. So basically the benefit is same like feedback plus feed forward, but it's very useful in high frequency noise and disturbance. We can say that it can be used for the dynamic system, the fluctuate processing or unstable process. So key features for cascade control designed to be successful. So secondary loop should reduce the effect of one or more disturbance. Secondary loop must be at least 3 times faster than master loop. So if we said about faster, normally level controller, flow rate controller, flow control or level control is one of the fastest control loop system. So the secondary loop should be tuned tightly. Cascade control block diagram. It used two additional components, sensor and controller, to form a second feedback loop by controlling both control and manipulated variable. Okay, we can see here. Okay, we have a process in here. So this process will be measured, the output of the process, which is our CV, will be measured first time by our primary controller. Will be measured first time with our main sensor, and then it will send the information to our primary controller, and then that information here will be input of our secondary controller. This input will be compared with the value that measured before entering the process, and it will compare here, and this controller will make an adjustment, will make a correction based on this error and send to the final control element to do the adjustment. It is a quite powerful control system actually. Okay, let's have a look on the case study for the simple feedback controller of chemical tank. Okay, in here we can say that in a single loop control, the controller set point is set by an operator and its output drive a final control element. Okay, this is a level control system. So this sensor is used to measure the level inside the tank. Basically, in the real process industry, this level will be measured like this. So basically, the sensor is attached to like this. So a level controller driving a control valve to keep the level at its set point. So here, this level controller will drive a control valve here to keep level in here at its set point. So at first, like what I'm explained before, this transmitter will measure the level inside the tank and send the information to controller. The controller will compare the value of measured here and also set point, and if there is a, based on the error of set point and also measured value here, and we send the corrective action for the valve to implement it, and it will adjust the flow rate in out from the tank. So for cascade control, okay, just now we only have a single level control. Now we want to add in cascade control. In a cascade control arrangement, there are two or more controllers, of which one controller's output drive the set point of another controller. Okay, that's mean here we have first the main objective of this system is to control the level of this tank, right? So this information is sent to the level controller here, and the output of primary controller here, this one is primary, it will become the input of the second controller here. So this is what is meant by this statement. Controller of which one controller's output. So this controller's output drive the set point. So this controller output will become the set point, the input for the second controller. For example, a level controller driving the set point of a flow controller to keep the level at its set point. So this level controller driving the set point of this flow control to keep the level in here at its set point. So the main objective still a level of the tank, but to fulfill this control objective, we need two controller, which is our primary control and also secondary control. The flow control in turn drive a control valve to match the flow with the set point the level controller is requesting. So that means the secondary controller, which is flow controller, drive a control valve. It will adjust the control valve with the set point given by the level controller. So controller driving the set point, the level controller is the example above, is called the primary or outer or master controller. So set point first is the information set point, the input of the set point is been fed into our primary controller, which is just now level control. The controller receiving the set point, which is our secondary controller. So the output from the primary, it will send to the secondary controller. It receives the set point for the primary controller. This secondary controller also called as a inner or slave control. So let's like what, for example, boss and leader with the workers. So the main point, the leader set the target, right? So leader get the information about the target that they want to achieve, and that leader give the target that they want to the worker, and the worker will do based on what requested by the leader. So that's the example of the cascade control. Okay, now I will show the case study on the exothermic chemical reactor. Okay, in here we have temperature control to maintain the temperature inside the reactor, and we also have a level controller to maintain the level of water inside the surge tank, here and here. So this control system will measure the temperature inside here and manipulate the coolant flow rate here. So that's how the control system, this temperature control system work. The temperature of the tank inside the tank here will respond faster when changed in inlet temperature than to change in a coolant temperature. So here is coolant temperature. So here in T in. So this temperature in here will change faster when received fit in here as compared to this coolant temperature. Therefore, the feedback controller effective in counter for changes in TI, and less effective in counter for changes in TC. So to cater this problem, we need to install Cascade controller so that we will detect the effect of this TC and also TI. So basically, the feedback control system here is used to cater any changes of the T feed into the system. Meanwhile, this another temperature control system, secondary control system, is used to cater any changes of the temperature coolant here. So basically, the primary, we set a set point here, let's say 100 degrees Celsius. The set point will send to this temperature, first primary temperature control. This temperature control will compare the value of set point from the measured value here, and the output of this temperature control, the primary temperature control, will be sent to the secondary temperature control. The secondary temperature control will use the output of this primary as a new set point for them. So that set point is used to compare with the measured value temperature coolant here. And then based on the error calculate, it will send the corrective action to the final element. Okay. Measuring TC and taking the control action before its effect has been felt by reacting mixture. If TC here increase, the coolant flow rate to remove the same amount of heat. So this coolant flow rate here is increased to remove the same amount of heat. So now I move to level control with and without cascade control. So figure 1.18, level control through direct flow control. We use level control in here with the level measurement here, and then make a corrective action to the manipulated variable. So figure 1.19, level control through the cascade flow control. So if we have a cascade flow control, we must know that we have two or more controller. So the primary here, we have a level controller, and then this level controller will send the output to the other secondary controller, which is our flow control. So this flow control will make adjustment of the control valve here in order to make sure the level the desired level value is met. So level control without cascade control. The control variable is liquid level. Manipulated variable is flow rate of the liquid. Sensor in here is liquid level of control variable. And measured disturbance. So we read the level of control variable here and also measured disturbance. So valve is used to provide the corrective action. Okay, level control with cascade control. Primary feedback loop or auto loop is used to monitor the control variable, which is our liquid level. This one is our control objective. So output of primary controller become the set point for the secondary controller. Secondary feedback loop or inner loop monitor the manipulated variable, which is our liquid flow here, and adjust the position of the valve. So here is manipulated variable. It's monitor here and then do the adjustment at the position of the valve. So this one is another example of cascade control. We have level control in here for ordinary feedback control. So cascade control structure we have like this. We have two controller, which is level controller is a primary. Flow control is our secondary control loop. So the working principle is the same like what I explained just now. So analysis of figure 1.20 and 1.21. Without cascade level controller, change in downstream pressure will disturb the tank level. With cascade level controller, change in downstream pressure will be absorbed by the flow controller before they can significantly affect tank level, because the flow controller responds faster to this disturbance than the tank level process. So basically the purpose of the cascade level controller is to cater any other disturbance that may cause fluctuation, changes, stability of the system. Because we have to know that in the system itself, the pressure, the temperature of surrounding inside the tank will increase or fluctuate suddenly. So to bear all these consequences, we need to install, if the system is highly dynamic or highly fluctuate, we need to install this cascade control so that they can cater all those disturbances. If the system is very simple and straightforward, there is no other external disturbance, or the system is very stable, it's not dynamic, and then we can use the normal feedback control system. Okay, advantages and disadvantages of cascade control. Advantages: controller respond quickly to the high frequency changes. Controller integrate multiple sensor reading together, prevent inner loop disturbance from affecting the outer loop. It reduces the dead time in variable response. Disadvantages: the controller is more complex. Tuning cascade controller is more difficult as the set point changes has more parameter. Okay, we need to have more than 2 set point, right? Additional controller and sensor can be costly. Okay, so until now, I hope you can clearly understand to what I'm explaining. So for the next slide, there is an example you can try on your own based on what I already explained before. Basically, the example is the same. You just need to understand the concept based on what I explaining before. So if you have any other question regarding this topic, you can directly ask me. So thank you.